Introducing PolarWave, the millimeter wave over-the-air test software. PolarWave is a real-time data display application which controls both the 3D rotator and a network analyzer to perform passive tests of single-element antennas. The essential feature of PolarWave is that the projection of data is in real time, and therefore, a simultaneous monitoring is possible without having to wait for the test to end. Should an error or any problem occurs, the test can be put on hold or stopped at the very moment by clicking the pause or the stop button next to the start button. Once the issue is resolved, the test can be resumed or be started over. The function of PolarWave in a nutshell is that it computes the antenna gain data and displays the radiation pattern of the test subject in a single 3D graph or 3 2D graphs of either polar or rectangular type with the data. Let's talk about the current screen while a presentational performance is running. On the upper right-hand side is a motion control panel that regulates the movement of the 3D rotator. The uppermost numbers are the current position of the test subject in two respective angles on the two-axis system. Below are the user preset angle values by which the subject rotates each time on the azimuth and after each cycle of azimuth on the elevation. Possible inputs are within 360-degree angle of azimuth and 180-degree angle of elevation. Currently, it is set to rotate by 15-degree angle for the presentation, but it's certainly possible to rotate by 1 degree or 5-degree angles as usual millimeter wave tests. Beneath the motion control panel is the frequency setting that configures the start and the stop frequency, and the frequency step which decides how dense the estimation should be. All values are linked to the network analyzer, and right now they are set to measure the band from 24 to 40 GHz by a 100 MHz span. Another strength of PolarWave is its user-friendly interface. On the left-hand side of the screen is a colored scale of the data that displays the maximum value as red and minimum value as blue. Naturally, it helps locating higher or lower points on the 3D graph. In addition to the scale, the 3D radiation pattern graph can be rotated or magnified in any angle. And the 2D radiation pattern can be shown on either polar or rectangular graphs, whichever suits your need. They can be zoomed in or out as well. Furthermore, based on the feedback of antenna developers who actually use this software, there are some visual functions for your convenience. First, the shading effect for a better view. Second, the plane cut function to slice the 3D graph by a specific plane to visualize a 2D polar graph on the 3D graph itself. Third, the plane sort function to navigate the graph immediately by a certain plane. Lastly, every frequency band within the range of initial setting can be displayed, and the 2D graph can show multiple bands on the same sheet for a convenient comparison and an easy recognition. We believe these small functions build up to make the most user-friendly, easy-to-view, easy-to-use interface. That is all about TESCOM millimeter wave OTA test software PolarWave for now. Thank you for watching.